Good morning, Geometry Honor students. So Mr. Chen again. So today I would like to talk about sections 3.4. Okay, so let's get started with this one. And let's go back to that original. Okay, so here are some of the Onebound problems you guys can get started with. Solving inequality. So those are pretty straightforward. So here's the solution you guys can check. Solving equations. Solving system equation, you can use elimination or substitution. Objective for the lesson today, so prove and apply the theorems about perpendicular lines. Here's some of the vocabulary. Perpendicular bisector, distance from a point to a line. So the perpendicular bisector of a segment, it's a line perpendicular to the segment at the segment's midpoint. And the shortest segments from a point to a line, it's the perpendicular to the line. This fact is used to define the distance from a point to a line as the length of the perpendicular segments from a point to a line. So name the shortest segments from a point A to line BC. Well, obviously that would be AP because that would be perpendicular. Okay, so AP is the shortest segments from A to BC. And write and solve the inequality for X. So we do know that this one is a right triangle, so that means the longest leg, which is considered x minus 8. So AP is the shortest leg here, or the shortest segment. So that means AC is greater than AP. So set up the inequality and then solve for x. So add A on both sides. So here's what we found for x. It's greater than 20. So here's another one, similar situation. So x minus 5 is greater than, well, it's less than 12, because 12, which is the longest leg of the right triangle. So set up the inequality. So AC is greater than AB. Substitute that the expression and the number, so and then solve for x. F5 on both sides. So x, it's less than 17, or 17 is greater than x. So here's some of the theorem that you guys need to know. So 3-4-1, if two intersecting lines form a linear pair of congruent angle, then the lines are perpendicular. Okay, so two congruent angle. So if two lines intersecting and form a linear pair that means 180 degree, then the lines are perpendicular. So two intersecting lines form linear pair of congruent angle, then lines are perpendicular. So 3-4-2, perpendicular transversal theorem. So in a plane, if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other line. So this one is one of the method that we talked about earlier for proving the parallel lines. Okay, so again, hypothesis and conclusion, if and then. 3-4-3, if two coplanar lines are perpendicular to the same line, then two lines are parallel to each other. So two lines are perpendicular to the same line, then those two lines are parallel. Again, that's one of the methods we talked about earlier before. Okay, so hypothesis and conclusion. So write a two-column proof. So given that line R is parallel to line S, angle 1 is congruent to angle 2, and we want to show that line R is perpendicular to line T. Okay, so started with the statement. So parallel line, congruent angle. So you do know that angle 2 and 3, those are corresponding angle postulates. Because two lines are parallel, so the corresponding angle got to be congruent. And using the transitive properties of congruence, so we do have angle 1 is congruent to angle 3. And since we proved that those angles are congruent, so two intersecting lines form linear pair of congruent angles, then lines must be perpendicular. So line R is perpendicular to T. So here's another two-column proof. So the good thing is that the diagram is given and also all the given elements. So it's already provided. So statement started with the given. So again, two angles are congruent. So what are those two angles there? They're considered alternate interior angle. So therefore that line EH is parallel to FG. We talked about that before for the previous sections. And then given that line FG is perpendicular to GH, so given, so lines are parallel, the other, well, FG is perpendicular to GH, so that means EH is perpendicular to GH, perpendicular transversal theorem. Okay, so the word problem here, no need to worry about this one. So this one, just make the perpendicular bisector. No need to worry about that. So here's some other practice problem that you want to do. So write and solve the inequality. So quite similar to what we did earlier. So we do know that df it's less than de, so that means 2x minus 3 is less than 25. F3 both sides divided by 2, so x is less than 14. So solve for x and y in the diagram. So two lines are perpendicular with that the common transversal. So this triangle, they must be considered corresponding, or considered equal to 90-degree perpendicular. So 10x equals 90, so x equals 9. And then plugging that number back to the binomial, solve for y, so y equals 4.5. So one of the two column proofs, so statement and reason. So again, quite similar to the practice problem that we went over earlier. So angle 1 is congruent to angle 2 given. So that means line Q is parallel to line R. Converse of corresponding angle postulates. And other things that we already know, it's given already. So P is perpendicular to Q. So Q is parallel to R, P is perpendicular to Q, therefore that P it's also perpendicular to R. Using that the perpendicularity transversal theorem. Okay, so that's it. So this one is a short lecture. So welcome, just go back to that the previous page, the previous part of the lecture for proving the parallel lines or the congruent angles. Okay, so I'll see you guys next time.